All right, guys, before we get started, are there any questions over the homework? Any questions over any of the homework assignments?
No. I don't think so. I don't think we need these, Jason.
Complex conjugates. Complex conjugate theorems is the first thing we're looking at. Now, the complex conjugate theorem states if a real function with coefficients, and a plus bi is an imaginary 0 for that function is 0 for it, then a minus bi is also 0. A plus bi, if we're given a complex number a plus bi, its conjugate is going to be a minus bi. If we're given the complex number a minus bi, its conjugate is going to be a plus bi. So if we looked at our first one here, 7 minus I, its complex conjugate would be what? So 7 minus I, its complex conjugate is 7 plus I. Negative 5 minus 5i would be? Almost. Negative 5 plus 5i. Because if a plus bi is this, if we have a plus bi, its conjugate is a minus bi. Questions on this so far? Now, before we move on to the next two, what we're going to do is we're going to actually multiply these two together. Let's see what happens. All right, guys, focus up here. So if we multiply 7 minus I and its conjugate 7 plus I, let's see what we get. Now, 7 times 7 is going to give us 49. 7 times I is going to be plus 7i. Negative I times 7 is going to be negative 7i. And negative I times I is going to be negative I squared. So we did this Friday. We've gone through multiplying these complex terms together. Now, 7i and negative 7i, what would that give us? 0, so that's gone. I squared is negative 1. So when we simplify down, like we did Friday, we'd still have 49. 7i minus 7i is 0. I squared is negative 1, so it's really telling us that we have 49 minus negative 1. Negative, negative makes it positive. Telling us that we have 49 plus 1, which is 50. If we multiply two complex conjugates together, we get a number. I's will simplify out every time. So the complex conjugate is 7 plus I. Their product is 50. The same thing would be true if we did this with negative 5 minus 5i and negative 5 plus 5i. Because if we multiply these together, negative 5 times negative 5 is going to be positive 25. Negative 5 times positive 5i is going to be negative 25i. Negative 5i times negative 5, or negative 5 times negative 5 is going to be positive 25. And we still have our I. And negative 5 times 5i is going to be negative 25i squared. Now, our first 25 here does not have any like terms. Our negative 25i plus 25i is 0. So our I terms there canceled out. Minus our I squared is still negative 1. Well, negative 25 times negative 1 is going to be positive 25. And 25 plus 25 is 50. Now, it's not always going to work out to be 50. It just worked out these first two did. But again, when we multiply two complex conjugates, we multiply a complex number and its conjugate together, we're just going to get a number. Negative 2 plus 4i's complex conjugate is what? Negative 2 minus 4i. How about 3 minus 6i? 3 plus 6i. Questions on these here so far? 10 minus 2i. Negative 4 minus 8i. Yes. Jacob, negative 4 minus 3i. Negative 4 plus, minus 3i. If a plus bi is its complex conjugate, a plus bi is a minus bi. So this would be negative 4 plus 3i. And then the next one, 8 minus 3i would be what? Plus 3i. We're changing the sign in front of I. So the complex conjugate for negative 7i would be? 7i. Because really we can say it's 0 minus 7i. So its complex conjugate would be 0 plus 7i. Because if a plus bi, if we're given a plus bi, its complex conjugate is a minus bi. What would the complex conjugate of 7 be? Because what's changing from a plus bi? A plus bi's complex conjugate is what? A minus bi, yes? Because 4 minus 3i, the complex conjugate is what? Negative 4. Yeah, because if a plus bi, if we're given a plus bi, its complex conjugate is a minus bi. If we're given a minus bi, its complex conjugate is a plus bi, yes? So what are we changing the sign of? We're changing the sign in front of the bi, our I term, yes? So really, what is it? We have 7 plus 0i, so its complex conjugate is 7 minus 0i. Because we're not given a complex part, so the number is still just 7. Questions on this here? Now, the whole reason that we look at this here, and these are nice, is that when we multiply two complex conjugates together, the result is just a number. We don't have an I term. So when we look at this first one here, I'm going to rewrite it bigger. You don't have to rewrite it. We need to get the I term out of the bottom of the fraction. We need to simplify that I term out. And the main way to do this is we're going to multiply the same thing on top and bottom. And it's going to be the conjugate of the denominator. So since the denominator of this fraction was 1 minus 2i, we're going to have to multiply the top and bottom by its conjugate, 1 plus 2i. And the reason that we do this is because if we look at the denominators first, when we multiply this out, 1 times 1 is going to give us 1. 1 times positive 2i is just going to be positive 2i. Negative 2i times 1 is going to be negative 2i. And negative 2i times 2i, negative 2 times 2 is going to be negative 4. And our I times I is I squared. Now we'll come back to the top of this fraction here in a minute. We're just going to look at the denominator, the bottom of the fraction first, simplifying it. Because our 2i minus 2i, 2 minus 2 is 0. Those are going to cancel. We still have our 1 because there are no like terms at the moment. Now our negative 4i squared, we have negative 4. But I squared, we can't leave it as I to a power. I squared is negative 1. So what we're saying is that we have 1 minus 4 times negative 1. Well, negative 4 times negative 1 is positive 4, telling us that the denominator is 5. So we really just multiply through to get the denominator to not have I. Now we also have to multiply the numerators. 4 times 1 is going to be 4. 4 times 2i, 4 times 2i is going to be plus 8i. 3i times 1 is going to be plus 3i. And lastly, 3i times 2i, 3 times 2 would give us positive 6, and I times I is I squared. Now at this point here, 4 does not have any like terms, but our 8i plus 3i, 8 plus 3 is going to give us 11i. Now we do have I squared, and I squared is negative 1. So 6 times negative 1 would be negative 6. So we got 4 minus 6 plus 11i. Well, 4 minus 6 is negative 2. So we get negative 2 plus 11i over 5. Now sum, I will take it as that there. We can also break it up into its two parts in its a plus bi form, where a in our case is negative 2/5, b is 11/5, and we get this here. So we had to use the complex conjugate to get the I term out of the bottom of the fraction. So we had to multiply the top and bottom of this one here by 1 plus 2i. Now part of the reason this works is because, bless you, multiplying by the conjugate will remove the I term, giving us a single number. But also multiplying the fraction by 1 plus 2i over 1 plus 2i, this is just a fancy version of 1. Anything divided by itself is 1. Questions on this here? Let's look at another one. 1 minus 4i over 2 plus 3i. I'm going to write a little bit bigger. And again, we're going to multiply this fraction by the complex conjugate of the denominator. Now the denominator, the bottom of this fraction is 2 plus 3i. So its complex conjugate would be what? 2 minus 3i. So we have to multiply the top and bottom of this fraction by 2 minus 3i. So this time we're going to actually multiply the whole thing to start with before we start simplifying. Now our 1 times 2 is going to give us 2. 1 times negative 3i is just negative 3i. Negative 4i times 2 is going to be negative 8i. And negative 4i times negative 3i is going to be positive 12i squared. We'll do the same thing with the denominator. Our 2 times 2 is going to give us 4. Our 2 times negative 3i is going to be negative 6i. Our 3i times 2 is going to be positive 6i. And 3i times negative 3i is going to be negative 9i squared. Now at this point here on top and bottom, we can start combining like terms. On top, the 2 at this point doesn't have any like terms. Our negative 3i minus 8i is going to be negative 11i plus 12 times negative 1, because we have to simplify that power of I. We can't leave it as I squared. I squared is indeed negative 1. On bottom, the 4 doesn't have any like terms, but our negative 6i plus 6i are like terms, and we combine them, we get 0i. Now our I squared, like on top, is negative 1. Now our 12 times negative 1 on top, we do need to simplify that, would give us negative 12. And on bottom, we have negative 9 times negative 1, which will be positive 9. And once we finish simplifying, we get negative 10 minus 11i over 13. Now we can split that up into its two fractions, negative 10 over 13 minus 11 over 13. Questions on anything we've done so far? Two plus 5i over 4i. Well, up to this point, the graphing calculator has been able to do most all of these here. So let's try typing this in. Alpha y equals inner will give us a fraction. So we can start off there. Alpha y equals inner to get our fraction. And on top, we have 2 plus 5i. Alpha y equals inter. So on top, we can say 2 plus 5i. So we'll do 2 plus 5. To get I, we're going to go second decimal place, second the decimal point. Over 4, second decimal. And once we type the whole thing in, we can hit enter. Yep, because the 84 plus doesn't like doing these, so we might have to type it in a little bit different. So instead of typing it in as a fraction, because fractions are just another way to say we are dividing the top by the bottom. That's all a fraction is. So let's type it in as the numerator divided by the denominator, the top divided by the bottom. So we'll do parentheses, 2 plus 5i, close parentheses, divided by, parentheses, 4i, close parentheses. See if that will actually give you something that works. .25 minus 0.5. All right, we're going to do one more thing. Math. So to get to here, hit math. There's a button red currently on the screen. So the division. Yep. So everybody, so you're still typing it in. Everybody hit math. Get to the screen. The first option in there, FRAC, is fraction. So if you hit enter, what is it telling the calculator? What we're telling the calculator is to take the previous answer and turn it into a fraction. Enter. So math, enter, enter. So it tells us that the correct answer for C is 5/4 minus 1/2 I. Keep turning off. It might be the batteries are dying. So let's try the next one. 1 plus 4i divided by 2 minus 3i. Did we all get a number that looks something like this here? As you're typing it in. As you're typing it in. I'll get you a different one. Yeah. And then I'll take that one and switch the batteries out. Yep. Now, we're not going to write this as the answer. We're going to go math, enter, enter, and it'll tell us that it's negative 10 thirteenths plus 11 thirteenths. So do we get that there? Any questions on how we type that in? We're able to all get that typed in and do that? Yes. Enter. Yep. Questions on how we did these? Yep. One, two, three, four. All right, guys, so this worksheet is your assignment. So problems 1 through 5. 1 through 5, you need to do two things. One, find the complex conjugate, so you need to state what that is, and then find their product. So you're going to find the complex conjugate and multiply it and the given expression together. Six through 10, simplify. You're going to divide each of those there, and that's it.